Hi, in this video we are going to look at how we can make use of the chain rule to differentiate functions such as y is equal to sine into brackets 3x plus 4. We already know that the derivative d dx of the basic function sine x is going to be equal to the cosine of x. In the current problem, the complication is that we have a compound function here as an angle, which is 3x plus 4. So the objective is to reduce it into a basic equation by doing the substitution. So if I let u be equal to 3x plus 4, then it follows that the function y is now going to be equal to the sine of u, something which we can differentiate with ease based on our previous knowledge. Now if u is equal to 3x plus 4, then du dx is going to be, we derive the right hand side with respect to x is just going to be equal to 3, and dy du is going to be equal to the cosine of u. Now the chain rule states that dy by dx is going to be the product of dy by du multiplied by du dx. So in the current example, my dy by dx is going to be dy du, which is cos u, multiplied by the derivative of u with respect to x, which is 3. Okay, so then that becomes 3 cos, in place of u I'm going to back substitute that initial substitution we made, so it's going to be 3x plus 4. So that's what my dy by dx is going to be equal to. As mathematicians, we're always looking to find a general result that is going to work in all cases, in all general cases, not just in a particular case as the one we have done. So let's consider a general function that looks like this. Y is equal to, say, sine ax plus b, where a and b are constants. In this current example, they were equal to 3 and 4. What we will do is go ahead and use the same strategy, because we don't know how to differentiate it if this is a compound angle. So I'm going to let u be equal to ax plus b. It follows then that y has to be equal to sine u. Differentiating this with respect to x gives us du dx to be equal to a. Similarly, dy du is going to be equal to the cosine of u. Now using the chain rule again, I'm going to have to find the product of these two. So dy by dx is going to be equal to a cos u, but in place of u I have to put my substitution back, which is going to be equal to ax plus b. Now looking at the two examples, you will agree with me that it seems as if we are going to differentiate the angle, and when we did that in the first example we got 3, and then after that we differentiated the trig function, so the derivative of sine is equal to cosine, and then we kept the angle the same. In this general case, it's exactly the same thing that we have done. We differentiated the angle, so the derivative of ax plus b is going to be equal to a, which we're going to put down there. We'll differentiate the trig function again. The derivative of sine is equal to cos, and so that is a general result that you can quote in future problems. So similarly, if I am given y is equal to the cosine of ax plus b, in keeping with what we have agreed on, the derivative dy by dx of this function is going to be equal to, so what we want to do is we want to find the derivative of the angle, and the angle is going to be a. Differentiate the trig function, it's going to be equal to the negative sign. The angle stays the same, so ax plus b, and consequently our result is going to be equal to minus a sine ax plus b. So even a more general result will be when we are now given, let's say y is equal to sine of an angle which is a function of x. Alright, so making use of the chain rule again, what we will do is we'll find that dy by dx is going to be equal to, we differentiate the angle, so the derivative of f of x with respect to x is going to be equal to f prime of x, and then we differentiate the trig ratio, and that tells us it's going to be equal to the cosine, and we maintain the same angle, so it's going to be f of x. Similarly, if we now have y is equal to the cosine of f of x, what we want to do is make use of the chain rule and say that the derivative of the angle is f prime of x. The derivative of cosine is negative sine, so it'll be sine f of x. The angle is maintained. Okay, what remains to be done now is for us to attempt another problem and see if we have mastered the approach. Okay, so here is a practice question. We are given that y is equal to 6 cos of 4 minus 3x, and the question is to find the derivative dy by dx of that expression. You can pause the video now and then attempt the question. Welcome back. I hope you had some success. So we're going to do the same strategy. Dy by dx is going to be equal to, the coefficient stays the same, so we're going to have it as 6. We find the derivative of the angle, and it's going to be equal to -3. We differentiate the trig ratio, and the derivative of cos is going to be equal to negative sine. We maintain the angle, which is 4 minus 3x, and then all we have to do is tidy this up. Multiply everything out. 6 times 3 gives us minus 18. Multiply by that, so it's going to be a positive 18 sine 4 minus 3x. Thanks for watching this tutorial. I hope that you found it to be useful. Cheers.